Hi, I'm Ken Rule, Senior Applications Engineer for Expand Machinery. Let's talk about the G71 Longitudinal Cutting Cycle, also known as the Rough Turning Cycle. The canned cycles in most turning controls are very powerful. They make manual programming easy and make global changes to the toolpath fast and easy by just a quick edit of the parameters in the code. The G71 Canned Cycle is a multi-line command whose job is to create roughing passes to remove material from a contour using the specified instructions. The line before the G71 command needs to position the tool for the beginning of the roughing cycle. In this example, we will position the tool at X 1.35 and Z 0.1. This position will be the starting point for the roughing cycle and also the point the tool will return to when the cycle is done. The first line or section of the command contains the parameters of the passes. The second line or section of the command contains the data of the passes. The third line is the beginning of the definition of the contour you wish to rough out. This definition can consist of many lines and will be described in detail later. For our example, we will use a simple contour from a 1.25-inch diameter material. The passes needed to remove the material look like this. We can use a G71 roughing cycle to do this in just a few lines of code. The first line of the G71 sets the parameters of the cut as such. The U value is the depth per pass that we want to use. U is a radius value and represents the actual depth of the tool in the cut. We will make this one 50 thousandths. So G71 will remove 100 thousandths off the diameter for each pass. The R in the first line represents the distance the tool will retract after the pass. The retraction will be both in X and Z axis at a 45-degree angle and can be set by a parameter. The control default is usually 20 thousandths. This is also a radius value and can be omitted. The H in the first line tells the control whether or not you have a pocket or a part of the contour that decreases in X. A 0 in H is a straight contour with no pockets, and a 1 in the H lets the control know there is a pocket or decreasing X value in the contour. The H can also be omitted if you have no pockets. In the second line, we tell the control the location of the contour data, finish amounts, and speeds and feeds for the actual roughing. The P in the second line is the sequence number of the beginning of the finish pass, and the Q is the sequence number at the end of the finish pass. The control needs to know what the finish contour looks like, so it can calculate the position of the roughing passes. We do this by programming a finish pass and define it by placing a unique sequence number before and after the finish pass. Now we need to tell it how much material we want to leave for a finish pass. U is the amount left in the x-axis. It is a radius value. W is the amount left in the z-axis. The F is the feed rate to be used while roughing. During the roughing, this F will override any F we place between N100 and N200. The spindle speed and tool number are programmed earlier in the operation and do not need to be placed on this line. The third line is the beginning of the definition of the contour. There are some simple rules to avoid confusing the control and possibly creating an alarm. The first line of the definition of the contour should be a unique sequence number. G0 and the rapid move you would make to position the tool for the finished cut. In this example, we will use N100 G0 X 0.5. The next line is the beginning of the finish cut. G1 Z minus 250 thousandths with a feed rate of 1.5 thousandths per revolution. The feed rate on this line will be used for the finish pass and ignored by G71 roughing cycle. After this, we will just program the tool as if we're making the finish pass. I will be using the comma R and comma C to program the radius and chamfer. We continue with an X 750 thousandths, comma C 0.1, Z minus 0.750, comma R 0.2, X 1.35. Since the last move is where the tool leaves the part, we'll place a sequence number on this line to tell the G71 that we are done describing the material we wish to remove. N200 X 1.35. The code between N100 and N200 is the finish pass. We will use this later. When we execute the G71, this is the passes we get. By going in and editing the U in the first line, we can change the pass depth and the number of passes. I will change the pass depth to U 0.03 or 30 thousandths. Notice the increase in the number of passes. Now we have programmed the roughing passes, but we still need to finish the contour. As I stated earlier, we have already programmed the finish pass. Wherever we want to do a finish pass, we simply have to program a G70 P100 Q200 finish cycle, and the machine will run the finish pass at the embedded feed rate. A typical program to rough and finish this contour with the same tool would look like this. If you want to use a finish tool, we can add a second tool and use the G70 P100 Q200 to do a finish pass using a different tool. G70 can be used multiple times after the G71 for cleanup passes. This concludes our talk on the G71 roughing cycle. Bye for now.